From the dawn of civilization, we've harnessed energy to power our world. In 2025, the world was still grappling with this question, relying on a mix of old and new technologies. But fast forward a century, and the energy landscape of 2125 is almost unrecognizable. Quantum energy, fusion power, and even the mind-boggling potential of black hole energy are now within our grasp. Let's embark on a journey through time, comparing the energy sources of 2025 with their evolved counterparts in 2125.
In 2025, fossil fuels were still very much a part of our lives, though their dominance was waning. The world was beginning to recognize the environmental and health impacts of these energy sources, and the push for renewable energy was gaining momentum. Coal, petroleum, and natural gas. These carbon-rich remnants of ancient life fueled our power plants, drove our vehicles, and powered our industries. They were the backbone of the industrial age, providing the energy needed to build and sustain modern civilization.
Imagine, for a moment, a typical car in 2025. It was a common sight to see streets filled with vehicles running on petrol or diesel, contributing to traffic congestion and air pollution. It likely ran on petrol or diesel, its exhaust pipes spewing carbon dioxide and other harmful pollutants into the atmosphere. This was a major contributor to global warming and respiratory illnesses in urban areas.
But by 2125, the era of fossil fuels is a distant memory. The once bustling oil rigs and coal power plants now stand abandoned, overtaken by nature. We've completely transitioned to cleaner, more sustainable energy sources. Solar panels and wind turbines now dominate the landscape, harnessing the power of the sun and wind to generate electricity. Fossil fuels are no longer extracted or used anywhere on Earth. The decommissioned facilities serve as a reminder of a bygone era, a testament to human ingenuity and the ability to adapt and change.
Picture a car in 2125. It's sleek, efficient, and runs on advanced technology that was once the stuff of science fiction. It likely runs on a quantum battery, a device capable of holding an immense charge and recharging almost instantly. This breakthrough in energy storage has revolutionized transportation and many other sectors.
The transition wasn't always easy, but the rewards, as we see in 2125, were more than worth it. Our cities are cleaner, our air is purer, and our reliance on finite resources has been replaced by a sustainable and renewable energy system that promises a brighter future for generations to come.
Back in 2025, solar energy was already a burgeoning industry. The world was beginning to recognize the immense potential of harnessing the sun's power. Governments and private companies alike were investing heavily in solar technology, aiming to reduce our reliance on fossil fuels and combat climate change. Rooftop solar panels were becoming an increasingly common sight, harnessing the power of the sun to power homes and businesses. Suburban neighborhoods and urban centers alike saw a surge in solar installations, as people sought to take control of their energy consumption and reduce their carbon footprints. But even then, the technology had its limitations. Early solar panels were plagued by inefficiencies, often struggling to convert more than 20% of the sunlight they received into usable energy. Shadows, dirt, and even the angle of the panels could significantly impact their performance. Solar panels were relatively inefficient, only able to convert a fraction of the sunlight that fell upon them into usable energy. This meant that large areas were needed to generate significant amounts of power, and the energy output was often inconsistent depending on weather conditions and time of day.
Fast forward to 2125, and solar energy has undergone a truly mind-blowing transformation. Advances in materials science and nanotechnology have led to the development of solar panels that are not only far more efficient, but also more versatile and durable. While we still use solar panels on Earth, they're vastly more efficient, often integrated into building materials themselves. Skyscrapers and homes alike are now clad in solar-absorbing materials, turning entire buildings into power generators. This integration has revolutionized urban planning and architecture, making cities more self-sufficient and sustainable.
But the real game changer is the advent of the Dyson sphere, a concept first proposed by physicist Freeman Dyson in 1960. This ambitious idea involves constructing a massive structure around the sun to capture its energy output on an unprecedented scale. Imagine a colossal megastructure, a sphere of solar panels enveloping the sun, capturing the vast majority of its energy output. This concept, once purely theoretical, has become a reality thanks to advancements in space engineering and robotics.
This incredible feat of engineering provides an almost unimaginable amount of clean energy, enough to power not just Earth, but our colonies on Mars, the asteroid belt, and beyond. The Dyson sphere has enabled humanity to expand its reach across the solar system, establishing new frontiers and pushing the boundaries of exploration.
In 2125, cities are bathed in the warm glow of energy beamed down from space. This energy is transmitted wirelessly, eliminating the need for extensive power grids and reducing energy loss during transmission. The era of energy scarcity is long gone, replaced by an abundance that fuels our technological advancements and allows us to reach for the stars. With virtually limitless energy at our disposal, humanity is poised to achieve feats once thought impossible, from interstellar travel to the creation of artificial habitats in space. In 2025, nuclear energy was a topic of much debate. It was a powerful source of energy, capable of generating vast amounts of electricity with minimal carbon emissions. But the specter of nuclear accidents like Chernobyl and Fukushima loomed large in the public imagination.
By 2125, however, the landscape of nuclear energy has been utterly transformed. We've moved beyond the dangers and limitations of fission and unlocked the power of nuclear fusion, the same process that powers the sun.
Fusion reactors, once a distant dream, are now a reality, providing clean, safe, and virtually limitless energy.
By the 2090s, fusion energy had become the standard worldwide, providing clean, safe, and abundant energy for all. Imagine a world where energy is no longer a scarce commodity, but a readily available resource, as limitless as the stars themselves.
Wind power in 2025 was a familiar sight, with vast wind farms dotting landscapes, their towering turbines spinning gracefully in the breeze. These wind farms were often located in remote areas, where the wind was strongest and most consistent, providing a reliable source of energy. The sight of these turbines became synonymous with the push towards a greener, more sustainable future. They represented a significant step away from the polluting fossil fuels that had dominated the energy sector for over a century. This clean and renewable energy source played a crucial role in reducing our reliance on fossil fuels. By harnessing the power of the wind, we were able to generate electricity without emitting harmful greenhouse gases. This shift not only helped to mitigate climate change but also spurred technological innovations and economic growth in the renewable energy sector.
By 2125, we haven't just harnessed the wind, we've taken this energy source to an entirely new level, literally. Advances in technology have allowed us to build high-altitude wind turbines that capture stronger and more consistent winds found at higher elevations. These futuristic turbines are capable of generating significantly more power than their predecessors, making wind energy an even more viable and essential part of our energy mix. We now capture wind energy not just on Earth, but from the atmospheres of other planets. This ambitious leap has opened up new frontiers in energy production, allowing us to tap into the vast and untapped energy resources of our solar system. The development of extraterrestrial wind turbines has been a game-changer, providing a new source of clean energy that can be used to power our growing interplanetary infrastructure. Mars, with its thin but ever-present winds, has become a prime location for vast wind farms. These Martian wind farms are designed to withstand the harsh conditions of the red planet, capturing the energy of its winds to generate power for colonies and research stations. The success of these wind farms on Mars has paved the way for similar projects on other planets and moons, expanding our ability to harness wind energy beyond Earth.
The evolution of wind power from those early wind farms to planetary wind harvesting is a testament to our drive to push the boundaries of what's possible. This journey has been marked by continuous innovation and a relentless pursuit of more efficient and effective ways to capture and utilize wind energy. Each new development has built upon the successes of the past, leading to the advanced technologies we have today.
These stations, marvels of engineering, harness the immense energy of Jupiter's storms, beaming it across the solar system to power our interplanetary civilization. The energy captured from Jupiter's powerful storms is transmitted via advanced energy beaming technology, providing a reliable and abundant source of power for our space-based infrastructure. This breakthrough has revolutionized our approach to energy production, making it possible to sustain human activities on a scale never before imagined.
The real breakthrough came in the 2080s with the launch of the first space-based wind energy platform. This platform, orbiting high above the Earth, captures the energy of solar winds and converts it into electricity. The success of this project has demonstrated the potential of space-based wind energy, opening up new possibilities for sustainable energy production in the final frontier. As we continue to explore and expand our presence in space, these innovative energy solutions will be crucial in supporting our endeavors. Back in 2025, the world was just starting to explore the potential of biomass and biofuels. Farmers were turning agricultural waste like cow dung and crop residues into biogas, a renewable fuel source for cooking and heating.
But the real revolution in bioenergy was yet to come. In 2125, we've moved beyond simply burning organic matter for fuel. We've delved into the very building blocks of life itself, unlocking the secrets of molecular energy. Scientists have engineered synthetic molecules capable of storing and releasing vast amounts of energy on demand, effectively creating biological batteries far more efficient than anything we could imagine in 2025.
The journey from basic biofuels to molecular energy was fueled by breakthroughs in biotechnology and nanotechnology. In 2025, the idea of harnessing the immense energy of space was still in its infancy. Scientists and engineers were experimenting with space-based solar power, launching satellites equipped with solar panels to collect sunlight and beam it back to Earth.
But even the most ambitious space-based solar power projects of 2025 pale in comparison to what we've achieved by 2125. We're now tapping into the most powerful objects in the universe, black holes. By 2011, humanity had cracked the code of harnessing energy from gravitational waves, ripples in the fabric of space-time itself, generated by the movement of massive objects like black holes.
This incredible feat was made possible by centuries of scientific progress and a relentless pursuit of knowledge.
Imagine a future where energy is not just abundant, but virtually limitless, drawn from the very fabric of the cosmos.
As we reflect on this incredible journey through time, the contrast between the energy landscape of 2025 and 2125 is truly awe-inspiring. In 2025, we were still grappling with the challenges of a fossil fuel-dependent world, struggling to mitigate the impacts of climate change and searching for cleaner, more sustainable alternatives. We unlocked the secrets of fusion power, harnessed the energy of the stars, and even tamed the unimaginable power of black holes. In 2125, energy is no longer a scarce commodity to be fought over, but a fundamental right, freely available to all. The evolution of energy from 2025 to 2125 is a testament to the boundless potential of the human spirit, a reminder that even the most daunting challenges can be overcome when we dare to dream big and work together